Alright, we're talking about even and odd functions. We're going to look at a couple of examples and make sure that we all feel pretty good about them. So, the first we'll talk about are even functions. And remember, a function is even if f of x is the same as f of negative x. And this is for all x. And what you want to think about here is, okay, if I plug in some value x and I plug in its opposite, they're going to be equal. Okay? And the easiest way to think about a situation where this happens is if you consider the function f of x given by x squared, where I square whatever the input is. Here, it's easy to think about. Think about 2. 2 squared is 4. Okay, if I plug in negative 2 squared is also 4. So in that case, it's easy to see where if I plug in an original value and I plug in its opposite, I'm going to end up with the same output. But it's very key that we test for all x, so we can't just plug into a negative 2. We actually need to make sure that no matter what the variable is, if I plug in its opposite, I'm still going to get the same thing. And so the best way to do this is to simply think about, okay, if I have f of x is x squared, what would happen if I plugged in f of negative x, or I plugged in negative x? So to test this, we would plug in negative x, and here we're squaring negative x, so we have negative x squared. And what is that? Well, I'm squaring it, so I'm multiplying it by itself. And here we can think about a negative times a negative is of course a positive, and x times x is x squared, so I end up with x squared, which is just what I ended up with when I plugged in x. So we can see that no matter what, whether I plug in the original version or I plug in its opposite, I'm going to end up with the same thing. So we can say, since f of x is equal to f of negative x, since this is the case, that means that f of x is even by definition, because that's what it means for something to be an even function. All right, moving on to odd functions. I know can be a little more confusing, so I want to look at an example a little more closely and then do one more example off to the side. If we think about evens and odds being different, odds are almost like the exact opposite of an even function. So for an even function, if I plug in some value and then I plug in its opposite, remember, if I plug in some value and then I plug in its opposite, they're going to equal each other. They're the same thing. But now, if I plug in some value, the opposite, when I plug in the opposite, I'm going to end up getting the opposite value. So if I were to plug in negative x, I wouldn't get the same as what I plugged in if I plugged in just regular x. I would actually get the opposite, or negative f of x. So let's see what that looks like. If I have some function and I plug in the opposite value, or negative x, what am I going to get? Well, I'm going to get the opposite of what I would have gotten had I plugged in regular x, the additive inverse. Okay, so let's go over what this means one more time. This says, okay, if you plug in the opposite value, you're going to get the opposite of what you plugged in, of what you would have gotten if you plugged in just regular x, and not the opposite of x. Okay, let's take a look at an example to help clarify this. Let's consider the function f of x given by x cubed. And let's think about what would happen if I plugged in 3. Well, 3 cubed is, of course, 27. And now let's think about what we would get if we plugged in negative 3. Well, negative 3 times negative 3 times negative 3 is going to be a negative 27. And so we can see they're not equal. But it's very clear that f of negative 3, when I plug in the opposite value, it is equal to the opposite of what I got when I plugged in positive 3. In other words, negative, or the opposite of f of 3. And so here we can see an example of where it's odd, right? Think about this. This is f of negative 3, analogous to f of negative x. And when I plug in the opposite value, I get the opposite of what I got if I plugged in the original value, the additive inverse. But remember, this is for all x. I'll remind us that this is for all possible x values. And so I can't just choose 3 and negative 3 and say I'm done with it. I've got to actually make sure that I consider all the possibilities. So if I want to show that this is odd, what I need to do is I need to be able to show that, hey, when I plug in the negative version, or the additive inverse of x, I'm going to get the opposite of what I've gotten if I plugged in regular x. So let's start by finding f of negative x. Okay, well, when I plug in negative x, I'm going to get negative x cubed. And similar to how I did this with x squared, we're thinking about negative x times negative x times negative x, which is just going to be a negative, and x times x times x, of course, is x cubed. And it's now fairly easy to see, all right, when I take the negative of f of x, I'm actually going to get that. So we'll find that. We found this part. Now we're going to find this part and see if they're the same thing. So negative f of x is simply going to be a negative times whatever f of x is. I'll make this very clear. This is my negative, and I'm going to negate whatever f of x is, which is x cubed. So we can see here that these two things are the same. F of negative x and negative f of x are equal, and so therefore it's odd. Okay? I'm going to go through one more example. I'm going to give you this function. So let's consider the function f of x, which is given by x cubed minus x plus 2. And we want to know, is this even, odd, or maybe it's neither? The first thing we want to do is we want to understand and remind ourselves what it means to be even and odd. So remember, if it's an even function, I guess I should have written them the other way, but that's okay. If it's an even function, f of x is equal to f of negative x. Remember, it doesn't matter. If I have opposite inputs, the outputs are equal. But if it's odd, that means when I plug in the opposite value, I'm going to get the opposite outcome. Just like that. So we want to test to see if it's even or if it's odd, and we really don't need to do both, because it's pretty easy to tell that this can't be even, because the largest exponent that we have here is a 3, it's a cube, and 3 is an odd number, and you cannot have an even function that has an odd exponent. So we're going to forget about evens for a second, and we're going to consider whether or not this is an odd function. So I want to think about really clearly, what are my steps going to be to test or prove that this is an odd function? Now, the first thing that I'm going to need to do is I'm going to need to show, actually the only thing I need to do is show that f of negative x equals negative f of x. Okay, well, to show that, my first step is going to be to actually find f of negative x. Then I've got to find negative f of x. And that third step is I've got to decide, are they equal? Let's go ahead and do that. First, we're going to find f of negative x. And so here I'm going to plug in a negative x for each of these. So instead of x cubed, I have negative x cubed minus negative x plus 2. I simplify, and I remember that negative x cubed is simply negative x cubed. Negative times negative is a positive, so this is positive x plus 2. Okay, we'll remember that. So of course, step 1. And we'll now think about step 2. So what is negative f of x? I'm going to highlight the part that we already know. We know what f of x is. It's simply x cubed minus x plus 2. But I am negating it. I'm taking the opposite of it. So I'm taking the opposite of x cubed minus x plus 2. And to simplify this, I simply distribute in, and I'm going to end up with negative x cubed plus x minus 2. And now step 3 is to decide, hey, are these two things equal? Well, let's look at what we simplified them to. The first two terms are the same, negative x cubed plus x, but one of them is being added to and one is subtracting 2. So they cannot be equal because something plus 2 can't be the same as that something minus 2. So my conclusion over here would be that f of negative x is unequal to negative f of x. So neither odd nor even. Alright? Good. Hope this was helpful.